guys, hope you're all doing well. Welcome to the second session of our course. I'm sure that you have practiced everything that we have discussed in our previous session, and now you actually have an IPE section of your own. Now, today we'll be discussing the modeling process regarding one of the most useful and beautiful metallic sections out there. And just like in the last session, we're going to do this based on a reference table as well, so everything will be done quite accurately. Now, what we're going to discuss today is called ICPE section. Basically, they are modified IPE sections, like people cut IPE sections like this. Then all of the cut sections would be joined up, and even an extra part like this one would be used as well. Now, it might look a little bit complex here, but when we start working on creating its family, you would see that how easy it is in fact. Now, as you can see, there's a specific geometry here. Like, if you take a look at here, we got this hexagonal shape, okay? We actually have half of it here only. Anyway, what I'm trying to say here is that there's a specific principle to creating this. Like, for example, we definitely need to consider the height of our IPE sections, all right? Now, what I can do here is I can go ahead and open up the Family and Type tab here. Then, for example, let's select IPE 10, apply, okay. Then I'm going to need a Save As. For the name, I'm going to go with ICPE. Let me do this correctly. Okay, save, and now let's see what should we do next. Let's go ahead and check an image related to this section to see what exactly we should do. You know what? I think we actually have a better image. Let me see. Yeah, this is better actually. So let's work with this one. We're going to talk about that one as well later on. Okay, guys, when we cut some IPE sections and then join them up together, the elevation that we got would be 1.5 times the H parameter. Now again, H would be the main parameter here. So for example, if the H parameter covers this area, after applying the modification, we would have a new H parameter, which we would indicate using a capital letter, a capital H letter, which represents the height of the newly created section, all right? Now, the thing is, the dimensions that are set here are actually based on the first or the previous H parameter that we had before. So what should we do about this? Well, let's see. So first off, back to the viewport, I'm going to enter the right view, and then I need to change up these parameters a little bit. The parameters that I've set here before. Like, for example, I'm going to change up the name of this parameter to capital H, all right? Then in the Family and Type tab, I need to specify a formula, which would be H multiplied by 1.5. Apply. Now let me go back to the reference table once more and check the H parameter for the IPE 10. It would be 10, obviously, right? However, the capital H parameter would be 150, which is exactly the case here, all right? Now, let's say instead of IPE 10, we are working with IPE 14. So, the first H parameter would be 140, and the second one would be 210. Now, let us check our reference table to back this whole thing up. IPE 14, 210, all right. Let me go ahead and set this back on IPE 10 again. Apply, all right. And by the way, this modification would be applied on all of the type catalogs automatically as well. So in other words, we already got 3 types of ICPE sections, as in 10, 12, and 14. And later on, we can easily just add more if we wanted to. Yeah, like ICPE 16. Look at it as some sort of a practice. Okay. So again, guys, the first step would be specifying the capital H parameter. And remember, basically, ICPE sections are created based on the parameters and features that we have in IPE sections. And by changing the size, like from ICPE 10 to ICPE 12, only the H parameter would change, and the rest of the parameters would stay the same. Now, as I said, this hexagonal form would be created out of joining up 2 separate segments. And this should actually be indicated when we draw the sketches. Don't draw a hexagon, for example, and reproduce it throughout the model. You actually need to have a demonstration on the 2 completely separate parts of our model. Now, for doing so, I'm going to go ahead and select this. Okay, these radial dimensions are kind of in a way. Okay. Now I need to split this part right from the middle And now let's just assume that we only got half of a section here like this, and we're going to use this one for our work. And now the other image that I showed you before would become handy. So let's see what we have here. First off, the main H parameter has been divided by 1, 2, 3, 4. Now, for example, here we got H and 4 or H and 2, and these would indicate the movement of this whole shape throughout the sketch that we got. Now, what should I do though? Well, I should go ahead and try creating these voids throughout my model, and then I need to reproduce the voids in the best way possible. So the main thing that we need to do here would be creating the void, in fact. All right, I'm going to start by changing my view to the front view, and this would be the edge on which we need to set the voids. However, we can't just start drawing the voids here because we need some specific parameters, and also the voids should be able to reproduce accurately. So here's the plan. Today we'll be creating the voids, and in the next session we're going to assemble the model. So I need to enter a family template here. For example, I'm going to enter generic model face base. Now, when I say face, guys, I mean that edge that I showed you before, like the edge that I said we're going to use for creating the voids, all right? So I'm going to do a double click to open up the template to enter the template. Now press U to open up the project's units tab. Just like before, set this on millimeters to decimals, and let us begin. Now, what we need here is actually a trilateral, more precisely, a half of a hexagon, okay? Now, for creating this, we can use the parameters and values that we have here. For example, this part is the H parameter. So based on this, back to the viewport, I'm going to press RP as in reference plane. I need one here, and then another one. Now, DI for setting the dimensions. Then EQ for equalizing. Maybe a bit smaller though. Then I need to specify the parameter, which would be H. So here we go. Okay. Now back to the image. Let's see what is the next part on which we need to work. For example, the length that we got in this area is being presented by H on 4. So let's go back to the template again. RP. Set a couple of reference planes here again. Then again, set up the dimensions, DI. Outwards to inwards, the same goes here. Now again, we need to specify the parameter. Now, I'm going to type the name down like this. Not going to use the division symbol. Because if we do so, later on when we are specifying the formula, we should put this inside parentheses. So guys, if you do want to use the division symbol, don't forget the parentheses, otherwise your whole formula would be ruined. Because it won't be counted as a name. Alright, okay. Now, for the formula here, it is quite easy. Just divide whatever value we had by 4. Apply, and OK. Alright, moving on. Let's see what else we got. Okay, according to the image, we have another type of elevation or height here. Now, as you can see, the entire part here is called H. We need half of it, so we need to divide this by 2. So let's go back to the viewport, activate RP, set the reference plane like this. Then DI for dimension. Okay, and after that, the parameter which is called H and 2. Alright, then back to the family and type. You know what, let me go ahead and set the name just like the last one. Now again, for the formula, divide whatever value we had by 2. Apply and OK. And now we can start drawing the sketches. Let me take another look at the image. Now let me remove this. What we need again? We need a void. So I'm going to select void extrusion. By the way, guys, when I move the cursor here, if everything got highlighted in blue actually, it would mean that the line is locked to the reference planes. And the same goes here. Now I need several simple clicks to create this geometry. And I'm also going to lock these lines to the reference planes as well. And now we shouldn't have any problems, for example, when we want to resize these. Yeah, see? Okay, let me select and lock these 2. All right. And also, I'm going to go ahead and remove these. And I guess we have 4. Yeah, 1, 2, 3, 4. Yeah. So I'm going to set H on 4 here, for example. This way, if ever the parameters didn't move together, we won't be facing any huge problems. I mean, if I try moving this, for example, these should move without any problems and error. Yeah, everything seems fine to me. Everything works pretty well. There's no problem. Oh, and you should actually set this based on this course. Don't forget that. Alright guys, moving on. Next up, we need to give our void a depth. I mean, assuming that this would be our face, let's give the void a depth. And again guys, when I say face, I mean the edge on which the void is going to be set and reproduct. Now, the depth that we need should actually be equal to the thickness of the face. Okay, this means, let me enter one of the views. This means that we need to work with that S parameter that we had before. So the depth of our void should be equal to the S parameter. Alright, now I need a ref plane here, and then I'm going to hide the ref level to set the dimensions more easily. So I'm going to set one here, and then call it S. Okay, then afterwards I'm going to move it here and lock it down. Alright, now let's open up family and type. For the size, we were working with IPE 10, right? So let's use this here as well. I'm going to set this on 100, and then I need to check the reference table again. Let me see. Alright, for IPE 10, S would be 4.1. Okay, so let's type it down. Alright, now I guess we actually have all the parameters that we need. Now we can actually try saving this. Let's simply call it void. Here we go. Now we can go ahead and load this into the project. I mean, our BIM template. Alright, let's see. We got ICPE here. Right, now I'm going to set this void on this face. Okay, the void is set, but it is not cut yet. Why? Well, because we haven't activated cut void with geometry yet. I mean, first you need to activate this option, then you can set the void on the face. Now load into the project once more, and now as you can see, everything seems fine. We successfully created and also set a void on a face or an edge like this. We somehow are gonna start our main work, okay? Now, the first thing that we need to do when we select this void would be specifying the void's parameters based on the parameters that we got in our current conditions. And remember, guys, the new parameters should be set based on the main parameter that we got, which would be H. Alright, so let's go ahead and create the parameters first. I'm going to enter the type properties. Now, you can set the H based on this, or you can go ahead and make it more distinguishable by typing down H1. Instance and OK. Now, for the rest of the parameters, they're quite the same. Like, for example, H on 4. Again, instance. OK. Now, the next one. This would be H on 2. Instance. OK. And then because S is a common parameter, we can directly use this. Alright, now after specifying the parameters, we need to specify their formula. For example, for the H1, we can type down H equals H1. Alright, here we go. Now for these parameters though, we need to use H1. For example, for the first one, we have H1 divided by 2. And then the next one would be H1 divided by 4. Apply and OK. Alright, now let's go ahead and check the dimensions that we got. For example, for the H we have 100, divided by 2 we have 50, divided by 4 we have 25, and for the S we have 4.1, which as I said is the same as here. Alright guys, moving on, I'm going to enter the front view and we have several points here that we need to discuss. Now, first off, to make sure that this would always be our starting point, instead of using a reference plane, we can use a reference line. Before doing that, let me select front view here. Okay. Now we can set a reference line here. Alright, now let's give it a parameter as well. Before that, let's go to the image and check the distance that we need for setting this parameter. If we count this area as our starting point, I mean this edge, without considering this part, this would be 2h in fact. And actually the same goes for this part up here. Now this part here is actually an extra part that we would usually cut, and then we set it, for example, on this side to complete our geometry. So overall, I can go ahead and set an h2 or h2 parameter here. Now for the void, we can go ahead and use the align to set this void based or according to this reference that we set here before. And obviously, and as I mentioned before, if we start moving this now, the void would move accordingly. Alright, let's move on to the next point. First, let me hide the ref level. Now again, a L, because we need to align the void to this line here. Alright, the next step, actually a very important next step that we need to take here, would be reproducting the void throughout this face. Now for doing so, I need to use array. Well, obviously we need to select the void. Now I need to set this on linear, then second, because we need equal gaps in between each void. Now I'm going to set this here, okay? And let's go with 4 here for now. Okay, seems like we're facing a problem because we've aligned this void to this lower edge here. When the reproducting or arraying process goes through, it is not able to cut this. Alright, so how do you think we can solve this problem? Okay, let's find a solution together. I'm going to enter the right view first. And then, just for now, I'm going to go ahead and unlock this and then move this edge downwards a bit. We can even use a number here, like a very small one, 1 millimeter. Alright, afterwards, we can lock it down again. Alright, the lock is set down there. Alright, anyway, now if we try doing this again, we will have our cut and it'll be applied quite accurately. However, let me ungroup these first. Then I'm going to hold the shift key, unselect this and remove the rest. Here we go. Now I'm going to try arraying this one more time. So select, then array. Okay, as I said, I'm going to go with like 4 of them. Okay, now for better demonstration, I'm going to set this on shaded, and yeah, everything seems fine. We're going to do something about this extra part later on, so don't worry. And now, this whole reproducting process should be done based on a specific principle, okay? I mean, if we go back to the image here and check the distance from axis to axis, would exactly be 1, 2, 3, 4 units. And the same goes here. Or I think we would be able to understand this better if we check the other image. Let me see. Alright, as I said, I need the distance. I need to check the distance in between these axes. The distance here would be equal to the h parameter, more precisely, that capital H parameter. Now, how we would be able to specify this gap here, though? Well, let's go back to the image one more time. Now, this gap should in fact be set from one center point to another. I mean, I actually need to set a dimension here, like this, from center point to center point, as I said. By the way, guys, try doing this as accurately as possible. Anyway, I'm going to set this on 1/5, and then up here I can select the H parameter, and everything will be done correctly. Afterwards, we'll get this warning, just hit OK here. Alright, next up, we need a new parameter. So, I'm going to click on the new parameter. Let's call it number. I want it to be an instance parameter. By the way, guys, we go with instance here because we want the number to vary based on the length. If we go with type, though, we'll always get the same number no matter what kind of length we have. For example, 2 meters, 3 meters, we'll always get like 5. So yeah, this would actually be quite of an important point that you need to consider. Alright guys, and as I said, we need to distribute the voids based on the length that we are working with. So to do so, I'm going to use a dimension here. Okay, let's call its parameter L, instance, and also reporting. So this specific parameter should actually be a reporting one. Okay, now I need to specify a formula for this, which would be L divided by the H parameter, capital H, by the way. Okay, here we go. Now let's check how much length we got at the end point. We have 3.40. Okay, How about this side? 50. Anyway, it doesn't matter. We just need to make sure that everything will be done correctly when we, for example, stretch this out. I mean, talking about the whole reproducting process, which is quite fine. I mean, everything seems fine here. Okay, let me give you another point, which is quite experimental. When you do such things, you should definitely save your work once and then load it into the project to see whether if it works well or not. Because if you create something completely, then try loading it into a project, if you face an error, you won't be able to find where exactly is the problem. So when you want to do something like this, do it step by step. I mean, add it or test it throughout a project partially and gradually. I mean, we've created this ICPE 10 and I'm testing it right now and it works pretty well, as you can see. And also we are able to test different types because we have a type catalog for this. I mean, when we go ahead and select another type here, as you can see, the size of the whole beam changes without any problem. And by the way, specifying an accurate and precise formula is also an important aspect. All right, now, we still need to do something else. I mean, we're not done yet. We still need to complete this whole thing. It's our main work, actually. And also, we have this extra part here that we need to emit. Now, what I recommend is using void sweep. Why? Well, because this is a linear element here. There's no curves. All right, then pick path, select the edge, then finish. Afterwards, enter one of these views, either right or left, doesn't matter which. Then we can use edit profile to somehow reduce this extra part. And just to make sure, we can use align to lock this profile based on the main references that we have here. Also gonna lock this part, then press tab and do the same here, and then finish. And basically just like this, we can cut that lower edge out of our form. All right, now let's move on to another important part of our work. Before that, let me just save this. Right, now, the thing is, this is just half of what we exactly need. Let's see how we can complete it. So, I'm going to enter the left view, then select this, press M, and based on this reference line, mirror it to the other side. Okay, here we go. We are not done yet. We still need to do more though. So, select, edit extrusion. What's happening? All right. Now, again, we need to lock all the sections, all the parts of our section to these references. And yeah, all the parts, like the wings, the body, everywhere. Right, the radius is okay. Now, regarding this extra part up here, did I lock everything completely? Let me check. Yeah, seems fine, actually. Now, we can set a dimension for this extra part up here. Now, lock and finish. And now, before anything, we can actually work on this edge as well. I'm going to use void sweep again. Select this edge. Now, what's happening here is that these two are collided from bottom to top. The collision is upwards. So, in fact, we should cut this part now. All right? So, just like before, select the profile, use align, and then just continue locking the profile with your reference. Tab. And okay. Now we have the cut here, but it is applied on both sides. We don't want this. We just want the lower side to be cut. So I'm going to select uncut, then select the top face to make sure that the top face won't be cut. Right now, we need to set the voids that we got on the lower face as well. Now, if you remember, we've worked as face-based up here. For this lower side, though, I don't really recommend doing this. If you're working with Revit 23 or 24, press PK, then select this lower face here to specify it as your work plane. Then press CM, and up here, select Place on Work Plane. Then you can set your void here. However, as you can see, the void has been rotated. So to modify the direction, I'm going to press space once before setting the void. All right, now I'm going to change up my view again. Okay, we just basically need to do whatever we've done for the top part in the lower side as well. So again, I'm going to start by locking these first. Okay. Now, before we move on to the rest, we should test this once to see whether we got any problems or not. Okay, so I'm going to select this on second. Then, for example, I'm going to go with 4. And as I said, now let's test this to see whether we got any errors, any problems, which seems like we do actually. Now, what didn't I do here was locking these endpoints. I mean, talking about these parts. So I'm going to activate align again, and then align the endpoints like this. Now, if I try testing or moving this again, we shouldn't really have any problems. Oh, and actually, we need to specify a fixed step distance in between these. So let's see what I can do here. This is locked. Press DI. Set a dimension here, lock, then select the edge parameter. Oh, and there's actually something quite important that we should do for both sides here. What I need to do is selecting these 2 voids in both sides on edit group, then again press AL, and just to make sure I'm going to lock this one, finish, and then again double click, lock, finish again, and then I need to select the number here because I want the number to be reproduced throughout the work as well. Alright, then after reproducing, we can test this again to see whether we got any further problems. If there was any error, it means that we still need to modify this further, right? Now let me load this into the project. I think there's a problem somewhere. Okay, take a look at this side. I don't think the cut is applied here correctly. I mean, let me test this. Let me change this a bit to see if the resizing goes through correctly or not. Right, no problem here. Let me go back to 12 again. Okay, and then I'm going to set this on 14. Yeah, seems like everything works fine actually. Now let's check the parameters. Let's see if they would work well or not. Alright, so we have ICPE 14 here. Let's also open up the reference table for having a better and more accurate comparison. Right, let me try creating some sort of a double window here. Alright, now ICPE 14, the height should be 210, which is exactly the case here, okay? Then we have 4.7, the same goes here. Then we have 6.9 as well. And I think the rest is fine. All right. And yeah, this is it actually. Now we have the beam that we wanted to create. And it works perfectly fine. Let me go back here and then select these. And then add the material parameter for both of them. Oh, they actually had the material. We didn't need to do that. Anyway, I can save this now. Alright, after creating the beam, we can easily use it. We can use it for drawing the sketches that we need in our project. For example, for this part, we can use BIM system on manual. Now we can specify this boundary for setting all the beams that we need. You know what? I don't really want to use ICPE here just yet, so I'm going to go ahead and change this instead to IPE 10, okay? Set this on maximum spacing. Now for the gap in between them, I'm going to go with, for example, 60 cm. Oh, this is actually 60 meters, I'm sorry. Okay, so 60 cm of gap in between all of these beams. Okay, so far so good. Doesn't really matter what we want to do with the main beams. And now, next we can enter the second level here. Seems like we get some tags as well, which we don't really need just yet. Okay, anyway, here I'm going to select beam again, ICPE 14. Let's test this once. Let me set one here to see if it works correctly or not. Alright, so let's see. We got ICPE 14 and it works without any problems. Okay, now we should move this underneath this part. So we can use align again. Let me see how much exactly we should move this downwards though. Seems like it's not that much. So in fact, I can move this here. Let me deactivate the consent. I can move this down. Right now, this joint, I can move this down. How much? It's just a little bit. Okay. Now, what I can do here would be reproducing this as our main beam. Like, for example, one here, then another one, and another one here. By the way, guys, I'm setting all of these here quite hypothetically. Like, if you want to do this yourselves, you should actually work based on the accurate dimensions that you got. Now, for placing these, there's actually an easier way that we can use, which would be using these reference lines. I mean, if I wanted to have equal gaps in between them, or if I had the first gap, I can use array. But if I didn't have the gap, I can start setting some dimensions, just like this. Okay, now EQ. Then afterwards, you might actually need to move these just a little bit, because when we align these, they might get misplaced, or for example, we might face an error. Let's see if we get an error or not, actually. I think we might. Yeah, here we go. Well, the wood actually got removed. You know, basically, these are just some bugs or some miscalculating problems that we have with Revit. Like, instead of just moving the beam, it'll move up everything. It'll mess up everything. So, yeah, anyway, just pay attention when you're doing such thing. I'm trying to help you become more and more familiar with the whole pattern that we have here. I mean, this would be one way for using such beams in our projects. And I guess we can even move this a little bit inwards, entering the second level now. Now I'm going to select this and move it right onto the edge of the wall. Right, now we can do the same for the rest of them. By the way, guys, this is something that we should have done before, actually, but this is just an example, so I'm doing it right now. Okay. Right now we have the beams, and we can, for example, use them for setting the rest of the elements that we might need, for example, for the ceiling. You know what? Let me try to elaborate on this. What I'm going to do is I'm going to use floor tools here to draw something like this here. Then I'm going to use the same floor here, this time in the second floor. Right now I want this to be set a little bit higher. Let's assume that the thickness is 15 cm. I'm going to give it a 50 cm offset. Again, completely hypothetical. Right now, if I go back here and set a camera in this angle, what we'll see would be this, well, beautiful, and you can even say quite detailed ceiling, okay? And you know what? Let me do something else. Let me try to add more detail here. To do so, I'm going to use the ICPE beams in these areas as well. I mean, more precisely, for example, I'm talking about this area. And also, for example, on this side, another time. I mean, let's say we are doing an architectural simulation here, right? However, using the items that we got in our structural discipline, we can basically create the whole structure of our current condition, okay? And not only this, but what we have learned or what we have created so far could actually be helpful in a real project. Right now, from the display option window, I'm going to go ahead and give this whole thing a good shadow effect. Then from the lighting, I'm going to increase the sun, the ambient to make this a little bit more brighter. And yeah, basically just like this, we are able to create a very beautiful and high quality model for the beams that we have based on our current conditions. And again, if there was any other thing left based on the current conditions, you can add them as well, like for example, columns. Okay guys, we are done here. Hope you have enjoyed our session. Don't forget to practice everything that we have discussed so far, and I'll see you next time. Good luck.